Hey everyone, I just wanted to go over question number 2 on part 2 of exam 1 review. Looking at this problem, we're talking about the time and hours someone watches TV versus their test score. We're given the data in 2 columns. We have to know which one's X and Y, so which one predicts the other, and we're given a scatter plot to look at. When I look at this, just looking at the data, I want to know if the TV hours and their test scores. So I want to know, does the TV hours, the amount of TV someone watched over the weekend, can that predict their test score on Monday? So X is the TV hours, and I'm just going to write that down. And Y is going to be the test score. So that's important for us to pick out. Okay, so part A, the first part of part A, asks for us to describe the strength and direction of the linear relationship from the scatter plot. So I'm just looking at the plots. I could do this 2 different ways. I can say, sorry, I don't want to write X. As X increases, Y decreases. This is my direction, right? This means a negative direction. It means I have a negative direction. I'm going to look at the scatter plot. The line, the points form a line. This looks like it's a linear relationship. Between TV hours and test scores. Okay. So it looks linear. And I can talk about the strength. It looks moderate to me. This is typically how we describe the scatter plot. We could also use what we would normally use for R. And let me just write or, so we know we have to do both. Or you can say something like, there is a moderately strong, or just moderate, negative linear relationship. Between TV hours and test scores. So this is typically what we would use if we had R. We're just looking at it, but it means the same thing, right? I have a linear relationship. I looked at it and it looks moderate in strength. Or you could say moderately strong, because you could definitely see a linear relationship. And negative, because as X increases, Y is decreasing. So you can use either one of those. On the solutions, you'll see I have this bottom one. But either one works if you're talking about looking at the scatter plot. If you're talking about R, I definitely want to see this. I definitely don't want to see X and Y in here. I want to see the context of the problem. So what is the problem about? I want you to include that, okay? All right, so that's the first part. And then the second part of A, I want to know the value of the correlation. This is my R value. So you're going to get this from your calculator, or Minitab. You're going to plug the 2 columns into 2 columns or 2 lists, right? Make sure you make a note of which one is X and which one is Y, like we already did, but maybe say list 1, list 2, or something like that. Column 1, column 2, if you don't have them labeled in Minitab. So when you're asking your technology to do the calculation for you, you know which one you have. Okay? So here we find the R value to be negative 0.757, which confirms my moderately strong negative linear relationship, right? Because if it was above a negative 0.8, so if it was like -1 to negative 0.8, then we're looking at more of just a strong and not moderate. Okay, so that's our value. Let's look at part B. Part B says the least squares regression line for this data is, this is, again, you're just using your technology. My equation is going to be the y hat equals AX plus B form, I want to know specific. What is it? So y hat is equal to negative 3.59 times x plus 89.8. So that's my regression line. Part C, I want to interpret the slope of the regression line. So the slope is equal to A, right? It's the number in front of X. That is negative 3.59. So what does that mean? That means for each hour increase in TV, test scores will decrease by 3.59, and I believe it's like points. I'll say, just put some units on it. Oops, I'm sorry, that was off. You couldn't even see that. Okay. So it's always for each unit increase in X, my Y is going to increase or decrease by the slope amount. Okay, so that's what we're looking for. Part D, I want to know how well does the line fit? This is my R squared value. So here I want to know what is it and interpret it. So R squared is just my R value being squared, but again, you'll be given this in your technology. This is 0.573. R squared is always positive, right? So what this means is that 57.3% of the spread or variation or variability in my Y, remember what Y stands for? Test scores. Can be explained by my line. So I can say, I could just write the equation of my line. I can say by the relationship, the linear relationship between TV hours and test scores. I can say different things there. Again, you can always put this into your own words. I just give you like a template and you can use that template. It's fine with me if you want to do that. Then the last part of this, I'm going to squeeze it in here. E, I'm looking for my error, right? So I want to know what is predicted for 6 hours of TV, and is the prediction higher or lower than what is actual? So for 6 hours of TV, I'm going to plug this in. I'm going to have Y hat is equal to negative 3.59 times 6 hours plus 89.8. And when I do that, I get 68.29. That's predicted. Now, actual, so I'm going to write actual here. And I'm going to actually look at the data, and I'm going to look for 6 hours of TV. And when I go down, it's the fourth from the bottom on the list. It says 65. So now I'm going to calculate the error. So the error is going to be my actual of 65 minus my predicted of 68.29. So it just tells me how far my line is off for that particular value here. So I get a negative 3. Is it 2? I wrote 2.6 and 2.9. I think it's 6. I'm sorry, 2.6. Sorry about that. I think this is 2.6. I apologize for that. Okay, so that's what we're looking at for part E.